Students, this time we are going to learn about the magnetostatic energy and energy density. Last class we derived the expression for what is the energy density in the electrostatic field. Now the question is all about what is the expression of magnetostatic energy when the current flows through an inductor. Let's consider here an inductor and it is connected across the voltage source V. It's a DC voltage source. Now the current I is flowing through the inductor. If so, the energy supplied by the source in time dt is given by voltage, current and time. So this is the energy supplied by this voltage source in time dt. So this much amount of energy is stored by the inductor in the magnetic field. So the moment we connect the inductor across this voltage source, current starts flowing and it builds the magnetic field around the inductor. So the magnetic field start growing slowly. So this is the expression of the energy supplied by the source in time dt. Now, what is the energy stored in magnetic field if this current I that changes from 0 to capital I? So that is energy stored in magnetic field. So W is integration. So here the current is only parameter which changes with the time. So it started from 0 and to I. At steady state the current is I. So we are integrating the expression dW. So here dW is V I dt. We already learned in basic electrical engineering the voltage across the inductor V is the inductor constant times di by dt. In this case, we can replace V with this expression. So L into di by dt I dt. So here we can cancel some terms on numerator and denominator side. You can take out the constant terms. So here the constant term is L. L is the constant of inductor. It is not going to change with the time unless inductor saturates. So L is a constant term. You can take it out, L, and 0 to I dt. So sorry, this is I dt because these two terms are common on numerator and denominator side. Now you are integrating I with respect to di. So integration of I is I squared by 2. So this becomes L into I squared by 2, where I changes from 0 to capital I. So finally the expression becomes half L I squared. Hence, the final expression of the total energy supplied by the source to the inductor when the current changes from 0 to I is half L I squared. This is very important. This is the energy stored in the electromagnetic field of an inductor. Let's take this expression as number 1, and then what is the energy density? So we know that the expression of L is mu naught n square A by L. This is like the capacitance expression, C equal to epsilon naught epsilon r A by D. Here A is the area of the capacitor and D is nothing but the distance between two parallel plates. Here A is the area of the inductor and L is the length of the inductor and N is the number of turns and mu naught is the permeability. Let us take it as expression number 2. Now substitute the 2 in 1 and 1 become W equal to half. Instead of L, this expression will go to here, so this becomes mu naught n square A by L into I square. Now we can rearrange this expression as W equal to half mu naught Ni by L whole square. So we will multiply an L to balance the situation and A. So Ni by L, this is an expression of magnetic field intensity H. H equal to Ni by L. So here again mu naught, in this place H will come H square L A. Again, so what is A into L? Area into length is nothing but volume. So then what is the expression of energy stored per unit volume? So W per volume is nothing but half mu naught H square. So half mu naught H square is energy per unit volume or energy density. So we can rearrange this expression as half mu naught H into H. So mu naught H is nothing but the magnetic flux density. So energy density is also a function of magnetic flux density and magnetic field intensity. So energy density of the energy stored and energy density of an inductor when current flow through this is half VH. If it is an iron core inductor, this expression becomes half mu naught mu r H square. If it is an air core, this is the expression. If it is an iron core, you need to multiply a relative permeability of the iron. It changes with the material. So finally we derived two very important expressions of magnetic electromagnetics, that is energy density is half BH, energy stored so magnetic energy stored in the inductor is half Li square. So please watch this video and take a note on your notebook and study well. Wish you all the best.